Okay, good afternoon. So today we continue to talk about the steel. So last lecture we mostly talk about materiality and steel type, connection, and finish type and structural requirement. So today we learn about the structural drawing and how we can read construction document set, and we can see fabrication process. We also see IBC, railing steel structure, and steel frame assembly. Okay. So let's look at the construction set first. So construction set, then how you can understanding steel framing drawing and how you can read steel framing drawing set. So let's talk about the steel framing drawing set first. So I just brought to the first the case study. So you remember about the project here. This UPTOWN phase 2. So this is a university dormitory for the Case Western University. So we working on this project, and then we using the type 1 construction, which we used the metal structure here. So we using the metal structure and metal cladding. So you can see the metal structure framing. You remember the last lecture we talked about how we can connect beam to beam or beam to column or column to column. We also talk about shear connection and moment connection. So we just simply using this knowledge to making out this structure. Okay. So everything is non-combustible requirements means you have to be the protect the fire. So that's why we're using the metal structure here. You see the metal column and metal beam, and then ready to construct the metal decking system here. So you see the metal decking system here, right? And you can just remember about how we can connect the beam to column. Remember about the pin joint, right, which is the shear connection and moment connection. Okay, so I think please kind of review yourself. You don't know about the shear connection and moment connection. So next things, so you can just see the another view here, and there is kind of different colors steel here. This is majorly using the hot formed steel, and then non-structural member we use the light gauge steel, which is the cold formed steel. You remember us what is different between cold formed steel and hot formed steel. I covered this issue from the last lecture, so you have to know about what is difference between the hot formed steel and cold formed steel, and what is different fabrication process between the steel system. Okay, please review from the last lecture. So from the structure, the framing. So I just kind of a simple modeling out to understanding how the steel, the metal structure composite to making out the single module. You can see the overall view here. You can understanding how column and beam connect, and then how the metal decking sitting over the metal beam. So this is simply making a single module, and then if you understanding about this system, then now you understanding of the structure framing, the construction. Okay, so after that we complete the project. So we also using the metal cladding system over the structure, and this is a complete image. And next one, it is the exterior view, and then this is the interior view. We simply finish out some finish interior material, and then finish the cladding material. So now you can just making out the finished version over the metal structure. Okay, so I just brought the construction document set for the structure drawing for the UPTOWN phase 2. I think you better to understanding how it looks like, and then we also learning how you can read this construction document set. So this is an actual construction document set from the UPTOWN phase 2. So you can have a general information about the steel framing structure, and then this is showing the ground level and then foundation design, and how we design the foundation, and then what is about thickness about the foundation, and also shows the column location. Okay, and then from the top frame we talk about the steel framing here. So when you see the steel framing drawing, it is following the grading system, and then this grading system basically following the column. You see the grading system here, and then you can see the W series, so you remember about the wide flange from the last lecture, then you actually can find the actual number from this nominal number here. You remember, right? So you can just find the actual number. You're understanding how much the depth you require and how much thickness you require. Okay, so you can see the column location here and here, and also you can find out the beam location in this location. Okay, so you simply find out the information about the beam and about the column from this document set. This is second floor, but just keep, you have to have each floor the framing. So this is a third floor framing plan, and then this is a fourth floor the framing plan, and this is a fifth floor framing plan, and this is sixth floor and the roof framing plan. You have to be including everything. Well, you guys probably noticed that the column doesn't have any dimension here. How you find out this column schedule? So you can find out this column schedule, this table here. So when you zoom in, you can just find out that you can see from the first floor, and then this is following the grid line. So you can see the size of the column here and here. Of course, column is different size depending on the height, because when you go up, it's kind of a support less weight. So it means have to be using the smaller column, right? It's kind of more efficient. So you can just find out the size of the column from the column schedule. So you can find out the actual beam, the size from each drawing set, but you can find out the column size from the column schedule here. Also, it shows how we can have the brace framing. Okay, you remember what is about the brace frame, right? It is support the resist lateral forces. So they have three different structure type to resist lateral forces. Please review the last lecture we already covered, but I just kind of briefly introduce. The first one is bracing frame, the second is moment connection, and third is shear wall. So please remember that these three different solution to give the resist lateral forces. Okay, so this is giving the more about the structure, the detail, how the beam and slab connecting together. What about the foundation detail? This is all provided from the structure engineer. So when you're getting this information as architect, you have to be adapt this information to our drawing, right? So that's why you should know about their language. You should adapt this information to your drawing. Okay, so let's back to our work. So just kind of read how you can read about the structure set. So I just simply summarize this set here. So when you just find out this drawing, so you can see the column, you can see the beam, right? You can see the girder. So you can just kind of find out. So you can just have a column location here, right? So you can just find out the actual column dimension from the column schedule. And now you can see the girder, okay, which is, you can see the W series, okay? And then now you can see the beam, right? So you can just simply understanding how you applied actual dimension from this W series. You just open the steel manual book and just find out the actual dimension and to adapt to your section, to adapt to your plan drawing. Okay, I think it's pretty simple to understand how you can read the structure document, and then you probably pretty easy to adapt this information to your drawing. So let's look at the fabrication process. When you complete the structure set and architecture set and they confirm, and then before construction, the contractor asks to the subcontractor, which is the steel fabricator, to make the steel framing or steel structure from their factory. It means the subcontractor, which is steel fabricator, they have to be provide the shop drawing. The shop drawing is very detailed information. It is usually provided from the subcontractor, and then giving the lots of information for the subcontractor and then information for the contractor. Okay, so anyway, let's talk about some process. The fabricator prepare the steel member basically from your drawing, basically from the structure engineer drawing. the fabricator prepared the shop drawing. This shop drawing showing the configuration of each member. Okay, and then they provide this shop drawing, and architect and structure engineer they review together. When they confirm, the fabricator also share the responsibility for design of the steel connection. So it means how it can connecting together, what kind of connection method they use. We talk about some option from the last lecture. Okay. After that, after we confirm everything, the fabricator start to cut to length, hope, drill, punch, weld, and add tab, angle, plate, and other accessory. So depending on our design requirement, okay, also indicating from the approved shop drawing. So they simply making out the pieces from the factory, or if they need some joint between the two members, they can welding together as well. So anyway, they just prepared all the structure members. Then they just awaiting the transportation to the construction site. When contractor asked the subcontractor, we are ready to construct your pieces, then they just shipping out to the site. Okay, and then each member also having the individual label. When you see the second image, you can actually see the designated number here. So what is the meaning about this number? This number means this is having the right location to build this framing following from your document set. So simply understanding individually labeling to correspond to information on the election drawing. So each piece can be assembled in the proper location. So you can just compare this number and then drawing set, and contractor can find the right location to elect this column. Okay. After that, you have to be electing and assemble each member together. Okay. But also you can see that the temporary cable with the turnbuckle. So what does this mean? Before everything permanently tightly together, it have to be temporary electing from the site. That's why this cable have to holding each member tightly before connecting together. Okay. So now we have to be discuss about the fire protection of the steel framing. So we also learning about the fire protection from your 345 and 545 class. What is about the fire protection? Why we need the fire protection? So fire protection is to resist the burning and withstand heat per IBC fire rating requirement. How you find out the fire rating requirement? This is depending on the construction type. Type 1 to type 2, it is non-combustible material only. So that's why it requires to use steel, concrete, and masonry. Type 3 and type 4, non-combustible exterior and combustible interior material. And type 5 doesn't matter, it's fully non-combustible material. So depending on your construction type, you have to choose the proper structural material. Okay. So why we need fire protection for the non-combustible material? Because you have to know that the graph. You can see above 500 to the 600, you see around here, the steel rapidly lose the strength. They rapidly lose the strength. Okay, so means when failed and lose the strength of the steel, what happened? Building will collapse, right? So that's why we have to provide fire protection from the non-combustible, which is a steel material. So just kind of, as we review the construction type on the first class, each construction type have a minimum fire protection hour. According as the minimum required fire protection hour, structure steel member require proper fire protection here. So you can see the defined building constructed to the varying degree of resistance of the fire. You see the type 1 to the type 5 construction. Okay, and then IBC say type 1 is most resistant requirement and type 5 least resistant. That's why type 1, type 2 have to use the non-combustible material, and also it shows the type 1 require 2 or 3 hours, and type 2 0 to 1 hours, type 3 0 to 1 hours, and type 4 is heavy timber, type 5 is 0 to 1 hours. So therefore most high-rise building have to adapt to type 1 construction, which is the most resistant material and most resistant requirement. And how you actually, this is just minimum fire rating hours depending on the construction type. Also you have to be checked. IBC 601, it shows the fire resistant rating requirement for the building element. So depending on the building element, it has the different fire requirement here. You see the construction type, type 1, type 2, type 3, type 4, and type 5. You also can see the building element. It is a major structure frame and bearing wall, which is a structure wall, exterior structure wall, interior structure wall, non-bearing wall, it means non-structure wall, exterior, you have to be checked, 602. We already covered the 602 table from the 345 and 545 class. Please check your lecture note. And then this is non-bearing wall, which is the non-structural interior wall. And then this one is the floor to floor, it's a slab fire rating hours. And then this is a loop slab fire rating hours here. Okay. And then basically you can comparing the type 1 and your construction type and building element. You can find the minimum fire rating hours here. But interesting thing is here, type 2B is all 0, right? So means you have to be understanding this is a very special case. Type 2B mostly using for the commercial space, but it's not very usual construction type. But you have to be remember type 1 and type 2 have to be using the non-combustible material, but type 2B is 0 hour. So means these material have no fire resistant. But you still have to use non-combustible material, but it doesn't have any fire resistant material. It means you cannot use the wood structure for the type 2 construction, but you don't need to be giving the extra protection for the type 2B. Okay, but once again, type 2B is not common the construction type. Okay, but we have to know how you actually giving the extra fire protection from the non-combustible material. So there's 3 options you can see. The first option is concrete and plaster. You see the metal structure, which is non-combustible material here. Simply cover the concrete or plaster. You remember, depending on the thickness of the concrete, it provides minimum fire rating hours. Okay, so it means you have to protect your steel from the concrete and plaster. So next one is gypsum board. You remember about the gypsum board. 1 layers of the gypsum board, which is the 1 hour fire protection. 2 hours, 2 layers of the gypsum board, it means 2 hour protection. Simply making the metal structure and the metal column or metal beam, you can add in some gypsum board covered up in making the fire protection. Next one, you can see the sprayed applied insulation. So spray applied fire rating insulation is the fastest and cheapest option. It is mostly used in warehouse and concealed structure. Because about the people don't want to see this finish because it's not look great. So that's why you can using for the garage, or when using this one for the office space, usually using the finish wall or finish ceiling to recess the finish. Okay, to recess this sprayed applied insulation. So now we're understanding about all 3 things, and then a little bit more to talk about spray applied fire material. It is most common to achieve equal level of the protection. It's very light. It seems like just spray on it. It is mostly using for steel high-rise structure. It's very fast to construct, and then it's pretty effective as well. Because anyway, when you spray on it, you just make out the finish ceiling here. You can totally recess it. So nobody care about this finish after covering the all finished ceiling here. Also, this is a very important point from the lecture, bracing. You remember about the bracing, which is, you can see the X bracing here. The X bracing is for the lateral forces, right? But this beam and column is for the live load and dead load. Please remember the fire resistant rating is a fire rating only required for the dead load and live load, which is for the beam and column, of course, other. The lateral forces, which is the structure for the lateral forces like X frame, X bracing, doesn't require the fire protection. Okay, so just kind of remember the structure member for the lateral forces is not required to be fire protection. Okay, so this is important to remember. So now we talk about the base plate. What is base plate? When you make out this column, this is column. Your column itself is hard to connect to the slab, right? That's why you need the base plate and have to be connecting the base plate connect to the slab. So just kind of you see that this image is better to understand. The base plate here, okay, and then this is column, and then simply connecting to the slab, right? So there are several different options to connect between the plate to the concrete. This is 2 hole, the 4 hole, and 6 hole, and another 6 hole. So you can choose the proper connection option depending on your column type, depending on the size about your column. So this is a simple drawing. Usually the base plate is set into the concrete because of the fire protection. Also, we don't want to shoot this plate outside. So it means you just making out the slab, making the hole here. You can just make out the slab. You just make out the casting like that. And then this is a place for the plate. You can just add in the plate here and then making out the column, and then you adding the lightweight concrete, which is without the rebar, and then lightweight concrete simply cover the dislocation. So when you see the outside, you only see the column itself. Okay, so this is the kind of process how you actually construct the plate and column, and how you construct the plate design. I think you better to understand it through this animation. This animation shows the working process at the metal base plate. Let's watch this video together, and then we talk about the right gauge steel frame. Pouring the lightweight concrete. Okay,